to Martin.
Lovely. Hi there, everybody. So I'm just going to rearrange a screen or two, and hopefully I can share my screen with you. So just bear with me a moment, and then I'll tell you about me, and I'll tell you about what we're going to share screen, what we're going to talk about this afternoon. So I want to, that's the one. Yeah. Make sure I'm sharing the right screen with you. So it's that one. Yes. Good. Super. Hopefully you can see my screen, or you can see my browser window. Certainly. Is that correct? Give me a thumbs up. Super. Excellent. So I'll start with an introduction. Who am I? Martin Callaghan, colleague of Eric and Nora and some of the other people here today. So I'm a lecturer in computer science at University of Leeds, an ex and sometimes research software engineer. So you heard one of my colleagues, Alex Coleman, talking this morning. So I used to work with Alex in the research software engineering team. I think my talk this afternoon is entitled Chatbots in the Cloud. Well, in fact, I decided, sorry, Nora, about a week and a half ago, I'm going to do something completely different instead. Well, almost something completely different, because the talk I was going to give was about how to create a sort of enterprise type chatbot using the tools that Microsoft Azure provide, which is all very nice and all very worthy. But you know what? It's not really very interesting. And as so many of us recently, sort of since November and into December and probably over the holidays, have been playing around with these new tools like ChatGPT, it got me thinking that, well, actually, this is going to be a lot more interesting. And I wonder whether there are some tools out there that allow us to use the underpinning language model that ChatGPT is built upon, and how we can actually go around building the tools that will help us solve the sort of research problems that we were hearing from people this morning. So I've got some particular interest, for example, in how we can help our undergraduate students improve their academic and technical writing. One of the things our students often need is lots and lots of feedback and prompts to help them improve the quality of their written work. And as we heard from Eric just at the start, the corpus that the GPT models are trained on is absolutely enormous. It's practically the whole of the internet. So there's an awful lot of background in there that we can tap into if only we knew how to build the applications that would help us prompt and develop and interact with the user. And it turns out that we can do, and it's actually not quite as hard as we might think. There is a brand new Python package called LangChain that was released just before Christmas. And one of the things that LangChain allows us to do is to interact with these large language models and develop applications like chatbots. So I thought what I'd do instead, Nora, is that we go on a little bit of a journey through large language models, GPT-3, LangChain, and see what we can do with it. So I haven't got any slides, but I have produced a Jupyter notebook with a few bits and bobs in it, a few thoughts. And I thought we'll take a little bit of a journey through that and see where we get to, see how it all works, and see what we can actually create. And I think it's a bit of fun, really, more than anything else. So I'll start off with a little bit of background. I've put some notes in here. So we're probably all in the same frame that these things called large language models are going to be a transformative technology. We're already seeing how ChatGPT is supporting us and helping us. But we just don't want to use a service that someone else has built. We want to be able to build our own tools around these technologies to solve our own research problems and support our students. So what we need is a readily available and easy to use set of tools that will help us do so. So the real power comes when we're able to combine GPT large language models with other sources of computational knowledge, and that's what our friend was talking about a little bit earlier on. If you've used ChatGPT, you'll know it can't search the internet. But in one of our little exercises, we're going to combine the GPT-3 language model with an internet search. and see how that can help us enhance the type of interaction that we can have. So I'll give you a little bit of background. So these large language models, huge transform-based models, the most common ones I think we've probably heard of are OpenAI. That's the name of the company. OpenAI have created these GPT models, and the latest one they've got is GPT-3. And there are a bunch of variants of GPT-3. In fact, the very latest one is one called Instruct GPT. It's the default that we're going to use today. They say it is far better at following user intentions. It is more truthful and less toxic in terms of the output it provides. Only less toxic, not completely not toxic. So that's encouraging, isn't it? So perhaps all the way through this, we should be considering our principles of responsible AI and not just trusting these systems to produce the output that we want to produce. And just about every company and research institute under the sun, I think, has developed a set of principles of responsible AI. I've popped a link in there to the Microsoft responsible AI document, which, if you're not familiar with that as a concept, is definitely worth a read, and it introduces you to some additional concepts as well. So that's OpenAI. I should probably point out that OpenAI's models are not free to use. There is a cost associated with this, and it's not particularly expensive. It's a few pence per 100 request tokens, but nonetheless they are not free. But nonetheless, they've put a huge amount of effort and money into training these models. So I suppose they're entitled to be able to get a little bit of that money back. So that's that. So in order to do so, we need to access the API, or application programming interface. And that's something that I've set up in advance. I've put my credit card details in, I've clicked a few buttons, filled a form in, and I've got what's called an API key that's going to allow us to access the model programmatically. For a later exercise, I want to be able to do some Google searching as well via my Python code. So I've also created an account with these people, Cert API, who allow me to do a programmatic search of Google's resources and to sort of hook in a Google search as well. As you might see, I've done 2 out of my 100 searches for this month already. And the package that we're going to use, so let's talk about that. So this brand new package here called LangChain is something that allows us to hook together all of these ideas and interact directly with large language models from OpenAI, from Bloom, even the public ones published on the likes of Hugging Space, for example, are all ones that we can access. But let's stick with GPT-3 because that's what we're probably most interested in at the moment. And let's go on a little bit of a journey. Just before I start to click some buttons and run some code, has anyone got any questions they want to ask? Just take a question or two, or shall we crack straight on? I'm assuming that's good. I can't see the chat, so I'm sure Nora will prod me if anything appears in the chat.
Yeah, sure.
Lovely. Okay, so if you can see my screen, okay, I'll take you on a little bit of a journey and I'll show you how we set these things up. So this is, again, following on from Alex's talk and a few questions this morning, this is a Google Colab Jupyter Notebook. I like Colab, I use it for lots of developments. Everything's already installed for me, except the things I'm going to need today. So I'm going to install this new package called LangChain using pip. So let's do that to begin with. We may already have it installed. There we go. And because we are using the OpenAI large language models, we need their API library as well. So I'm just going to install that. So downloads from their website and installs. That just takes a moment or two. And then in advance of this, I have created accounts on OpenAI and on Cert API, generated this key, and I'm going to pop that into my environment as well. So for any of you thinking you can just snapshot these and use them in your own later on and charge to my credit card, that's not going to happen. I will delete these as soon as we've finished today, just in case. So I'm just going to link into those two API keys. I need an extra package, one that lets me do some Google searching, but that should be everything that's set up in advance. Okay, so super duper. So now I'm ready to roll, got everything that we need. So as I said, we're going to be using Instruct GPT. You can find a little bit about that on their website, but it is one of the latest versions of the GPT-3 large language model that underpins services such as ChatGPT. So as we said, supposedly better at following user intentions, supposedly more truthful, and supposedly less toxic. So it's grown up a bit, it's knocked off its rough edges, and hopefully it's going to be a little bit nicer to us. So we will see, won't we? Okay, so let's move on. So we've done some setup, and before we can actually build a language model application, we need to know a few basic principles. We need to know how to interact with the API. We need to know how to get some things out of the model in order to start building up an application. So the very first thing that we're going to do, one of about 5 things in our building block of tools, is to be able to call our model on some sort of input. So let's say we're trying to create an application that generates short and snappy names for our research projects. Now, I always struggle with this type of thing, and I'm sure there's a course that you can go on to help you write these short and snappy names. But let's see whether OpenAI's GPT-3 can actually do that. So the first thing that we need to do is import this little bit of wrapper code that allows us to link into the API. So I'm going to do a little bit of typing and sort of copying and pasting here, just so we can build this up bit by bit. So we've linked to the LLM. So we need to initialize that wrapper, and we want to try and generate some random outputs. So in order to do that, random outputs. Apologies for my spelling mistakes. So we're going to generate some random outputs. So there's a parameter called temperature. And what we're going to do is you're going to initialize our large language model wrapper with a high temperature, which means that it's going to be more random. So OpenAI, and it gives me hopefully a whole bunch of things here. Yep. So I'm going to do the temperature equals 0.9. Okay, so I'm going to initialize it with a high temperature, so between 0 and 1, and see what it generates for me. Okay, so I've now got a link and a wrapper already set up. So the next thing I'm going to do is I'm going to give it a little bit of a prompt, and we're going to see what we actually get back. So here's a bit of code I wrote earlier on. So I'm going to create a text prompt, and this is the type of question that you are typing into ChatGPT. So what would be a good name for a research project that creates chatbots for student education? Okay, so I've created that as a variable. So let's now run that via that wrapper and see what we get back. So I pass LLM my text, and I print out the output, and providing I've run all of my API keys, what we should get back is not an error. Oh, there we go. So we get back a name for our project. So a name for our project is AI Enhanced Education, Developing Chatbot Assistance for Student Learning. Well, that sounds quite good, doesn't it? Now, there's a fairly good chance that if I run that again, I might get the same answer or something different. So there you go. I get a different answer, don't I? And let's try it a third time. There we go. So it's coming up with snappier titles, isn't it, each time? So that was setting the temperature to 0.9. So that's a high degree of randomness. So that means if I run it again and again and again, I'm going to get some very different sorts of answers. And we can vary that temperature anywhere between 0 and 1 to help randomize the output, to make it, in fact, a little bit more imaginative. Okay, so that's our most basic building block. That's creating a lang chain wrapper and creating a simple prompt and poking the GPT-3 API with that prompt and pulling back an output. So that's cool. So that's the easiest thing that we can do. Most often, though, when we're building an application or when we are creating something more complex, we're not sending user input directly to the large language model. What we're trying to do is we're probably trying to take that user input, constructing a prompt, a complex sentence or couple of sentences, and sending that to the LLM instead. And it turns out that this is the most crucial bit of generating applications or creating applications that use GPT-3 models, is generating the prompts. And there isn't really an automatic way of doing this. There isn't another engine somewhere that's going to write prompts for you. This is your skill and knowledge of your domain and your ability to write that in precise English. So this is a key skill that people are going to need. I think people are going to need to work on developing if you're going to create applications, is learning how to write good prompts. So some of my prompts might not be so good. So we'll see what we get out of the large language model. And coming back to that precision and toxicity, this is where you need to be careful about the language that you use, because if you phrase a prompt with fascist overtones, let's say, you are going to get back some fairly dodgy answers. So you need to think about how you phrase your prompt in the most appropriate way. Okay, so let's move on a bit and have a look at defining a template for a prompt and see how that bit works. So I'm going to define a template for a prompt, and this time I'm going to say from lang chain dot prompts import something called prompt template, and this allows us to build templates for prompts. So I'm building this prompt for GPT-3. I'm going to call it prompts. I'm going to base it on this prompt template thing, and it's got a little bit of a structure to it. So same idea as before, fancy names for a research project. So it needs at least 2 parameters. It needs some input variables. Now, in my case, the input variables I'm going to ask it for are going to be something called project name. So that needs to be a sort of variable type thing. Project name. So there we go. And I need to have a sort of phrase template that I'm going to plug in that input variable into. So it's basically the stub part of the question from before. So if we had a look at that before, so the stub of the question is, what would be a good name for a research project? For research projects, I might rephrase it a little bit. For a research project that investigates like so. It's a research project that investigates, and this is where I put the variable in afterwards. So it's going to plug in whatever I stick in that particular input variable that I've named project name. And in this sort of Python-y replace model, I do something like that. So I've generated now a template for a prompt where I can give it any particular project name, and it will build a prompt around that template and then send that prompt into GPT-3 and generate for me an answer. So I do need to put a little comma at the end of that, but there we go. So that's my template for my prompt. So it's going to take an input variable, and it's basically going to tag it onto the end of the prompt phrase, what would be a good name for a research project that investigates something. Okay, so let's just run that cell. So we've got that bit saved, and we can now have a go and see how it works and see whether we can actually build a prompt around that, and then run it via the language model. So let's just print it out to begin with. Prompt.format. Let's give it project name. And we might do something completely different this time. And let's say something like fluid dynamics for bridge design. Now, if anybody's got their own little problem and they want to suggest something in the chat, once we've done this one, we'll pop a couple of others in and we'll see what it generates back and make sure that this actually works. So if Nora can keep an eye on whether anyone's got any suggestions for us. So there we go. So what it does is it builds this little prompt for us. What would be a good name for a research project that investigates? And you can see it's plugged in fluid dynamics for bridge design. So that bit works. So my Python stringiness actually works. So that's good. So I can create a prompt now. Has anyone made a suggestion?
Not yet.
Not yet. Well, we'll stick with this one. Always have one prepared. Okay, so I can create a prompt. So I know how to build my own prompts now using a little bit of Python and this prompt template thing. So what we need to do next is to work out how to get that into GPT-3 and to actually build an application to build a more complex question. So that's quite fun. Okay, so we know how to do that. So what we're going to do next is working out how to combine the prompt and the large language model together and build something called a chain. Now, a real application isn't just one of these primitives. It's not just a prompt template. It's not just a simple prediction. It's going to be a combination of them, and often a complex combination of them, in order to create a more natural looking dialogue with the large language model. So LangChain provides this construct called chains. Chains are like any other chain, made up of a number of links, a number of individual components, where those individual components can be those primitives like the large language model prompts that we looked at to begin with, the very first thing, or they can in fact be other chains. So it allows us to build a collection of ever more complex questions and interactions in order to drill down into the complexity of the language model and extract something that we're going to be able to use. Okay, so let's have a look at how we can do that. So right, here we go, a little bit of a cell there for you.
So Eric has a suggestion here.
Go on.
Yeah, so he's saying, what would be a good name for a research project that investigates chatbots for student education?
More generally, I'm suggesting put back the answer into the question to see if it generates something even better. Because chatbots for student education was one of the outputs of your suggestion.
It was. Well, in fact, you're quite right. Should we pick one of those? Should we pick that one? Oh, yeah. Let's take that one.
Yeah.
Right. Let's pick that one. Good one. Let's see what it generates. Project name. Let's pop that into there. So we know that we can actually generate the prompts. Good. And we'll see what we get back out of it when we have a look at that in just a moment. Okay, super duper. So what we want to do now is extend the past example. We want to construct an LLM chain, which takes that user input, formats it with a prompt template, and then passes that formatted response onto the LLM. So I've got a sort of pre-written bit of code here, so that I'm not spending all of my time typing, which is good. So same sort of idea as before. That's exactly what we've got. We've linked those things together. We generated a prompt. We've got a hot large language model link ready. And what we now want to do is link those ideas together and run it with a suitable name. So let me just run that cell. So we've now got that, and let's build a chain. So this idea is linked together the LLM, the prompt, if you like, that question, together with that complex prompt that we've now just built. And we're starting to build up a set of tools that allow us to interact with GPT-3. So I've imported this thing called LLM chain, and I've created a chain that links together the original prompt, the original question, interacting with LLM, and linking it via the prompt that we've just generated. Okay, so we've sort of got that working. That looks good. And let's run that again. And we need to run that chain now, and we need to give it a suitable seed name. And Eric suggests using something that it created for us earlier on. So let's take that one, Chatbot Enhanced Student Education, and let's pop that into here. So what that should do is link those ideas together, poke it into the large language model, and it gives us back another name. So we asked it to give us a good name for a research project that investigates Chatbot Enhanced Student Education, and it's given us the name Chatbot Enabled Student Learning, Exploring the Benefits of Using Chatbot Technology in Education. So let's run it again, and we should get a slightly different answer this time. Yeah, and run it again, and we get a slightly different answer again. That's quite interesting, isn't it? There we go. So that's still very basic, still very, very basic. So let's make it a little bit more advanced. And this is where it gets a bit dangerous, and it might not work, but we'll see. So the chains that we've run so far sort of run in a predetermined order. But LangChain provides us yet another facility, something called agents. And agents themselves use AI to determine which actions to take and in which order. And this is where we're sort of adding in the sort of intelligent artificial intelligence in order to make our technology tool appear a little bit more human. So what we might have here is actions that could be using a tool and observing its output, or returning some output to the user. So here we've got some new concepts which have a particular meaning in terms of this sort of language model creation. There's this concept of a tool, or this idea of a tool, which is a function that performs a specific duty. And this is something like Google search or database lookup, or actually interacting with a programming language like Python, or some other chains that you might have written. And the interface for a tool, so we write a function in Python that expects to have a string as an input with a string as an output, and it does some magic stuff in the middle. It needs access to a large language model, which is the language model powering the agents. And we might have an additional agent to use. Now, out of the box, LangChain provides a bunch of agents for us that do particular things. And there's a couple of interesting things here, is that there is an agent called Conversational React Description. And this React conversational agent is one that is looking to be quite interesting because it's a set of packages that allows us to create complex conversational logic on top of a chatbot. ChatGPT uses a React conversational engine, and it uses it to parse the user input, and it uses it to create more friendly sounding English in the response back to you. So we've got a bunch of these tools, a bunch of these agents that we can link into. We've also got a bunch of tools, and the tools are also quite interesting. The one, well, in fact, we're going to use a couple. We're going to use this SERP API one, which is a way of interacting with Google search engine. As you probably know, with ChatGPT, it doesn't do a Google search. It can only give answers on what it knew last September. But wouldn't it be fantastic if we could enhance GPT-3 or ChatGPT with a live Google search as well? And it turns out that we can, using this tool called SERP API. And we're also going to do another one as well, which is something that allows us to solve complex mathematical problems expressed in words. And that is quite interesting as well. And this one's called PelMath. And we're going to join a couple of these things together in order to enhance our interaction with GPT-3. So let's have a think about how that might work, and make a few links and take it from there. So I'm going to load a few more libraries that I need for this one, which are our ability to interact with agents. But I'm also going to create another link to a large language model, go overwrite the existing one, because I'm going to do something numerical this time. I'm going to get it to do some word maths and to do some searches. I don't want it to go all random on me. I would actually like quite precise answers. So I don't want it making up stories when it's doing maths. So I'm going to set the temperature to 0 for this one. So I've already installed the package a little bit earlier on that allows me to do Google searches. I've got an API key for this SERP API. So I should then now be able to go on and actually create a Google search. So I'm going to need to load a couple of those tools. So the two that I need to use are the SERP API one, but also the PelMath one as well. A slightly different version actually called LLM Math. That's going to allow me to do some sums. Oops. I did not want to do that. So while I wasn't looking there, I inadvertently made that a text field instead of a code field. So that's what you get when you're not paying attention. So let me pop that into there. Okay, so I'm ready to do a search and I'm ready to do some maths. So I now need to initialize one of my agents, tell it which language model I'm going to use, and the type of agent that we want to use as well. So I've got some pre-written code for that, and then we're going to come up with a question. And this is a bit of a daft one, so I apologize in advance. There we go. So we're going to initialize an agent with the tools that I've just mentioned, large language models, with an agent called zero-shot React description. And that's that sort of more conversational agent to allow me to ask interesting questions in a more conversational way, and for it to respond back to me in a more conversational way as well. Okay, so let me do that. And then let's ask it a question. So let's try this one. So I'm going to ask it the question. Now, I know this is a bit random. So who is Brooklyn Beckham's wife? Okay, so that's an internet search. What is her current age? That's also an internet search. Raised to the 0.0 0.23 power, something like that. So the large language model itself might know who Brooklyn Beckham's wife is. I don't know who Brooklyn Beckham's wife is, but I do know he's married. It certainly won't know her current age because GPT-3 was created last autumn. So that's going to need to be an internet search. And we're going to need another tool, which is based on LLM math, that allows us to take a mathematical problem expressed in words and actually do it as a calculation. So that's actually quite complicated. There's some very complicated logic going on there, that we have this high-level wrapper with this Python package, LangChain, interacting with a couple of tools and a couple of agents, and interacting then with the language model underneath. So let's see if it works. Let's see what happens. I don't know whether it will or not. So let's take a look. Now, let's just pause for a moment and look at what's going on there. It's having a conversation with itself. It's pulling my question apart. It's working out what questions it needs to ask. And it's working out what questions it needs to ask itself to come up with an answer. It's then asking itself, how am I going to tell that back to the user? Now, I don't know about you, but I think that's pretty astounding, really. And it's very, very simple to interact in this way. So look at that. It's rephrased the question. I need to find out who Brooklyn Beckham's wife is and then calculate her age raised to the 0.23 power. So it knows it needs to do a search for Brooklyn Beckham's wife and gets back an observation and answer. It now knows it needs to do Nicola Peltz's age, now that we have her name, and it needs to do another search. Comes back with 28 years. It knows that years, it needs to take years off and take the 28th, the number of years, and then raise that to the 23rd to the 0.23 power. It knows that that's a calculator action. It knows how to express that sentence as a little, as a calculation. And it knows which one of those agents to go off and use in order to produce that calculation. It gives me an answer. So it's now thinking to itself, I know the final answer. It finishes the chain and it uses the zero-shot react description LLM to generate for me a nice English sounding phrase as well. So there we go. So that's how we create and how we use some of the tools underpinning what goes on inside ChatGPT. I think what it does allow us to do is that now we've got a building block of parts. Any of the research questions that we've got or the tools that we might want to build to support our students now become a little bit more straightforward. We're not having to interact with a tool that someone else has created for us. We can now build our own tools. But potentially it gets a little bit more interesting because remember what ChatGPT does within a conversation thread. It actually remembers what we said in previous questions, and we can use it to build on and enhance what's gone on previously. So we can add state or memory into our chains as well in a very similar way to the way that ChatGPT does. So it remembers what's gone on in previous interactions. And this is what we need in a chatbot, isn't it? We need it to remember what it said, so we're not constantly having to ask it the same thing over and over again. And it turns out that LangChain provides a bunch of specially created chains to help us do this, which is one called conversation chain that lets us actually do that. So let's have a little look at that, just to have a little look about how we would start off using it, because I do want to talk a little bit more about chatbots before we finish. So we're going to import this conversation chain again. And we're going to use that on a more precise conversation. And let's try a few more interactions or conversations as well. So it's going to remember what we said in previous chats. So the first thing I said, so that the prompt is conversation.predict. So I'm saying, hello there, hi there, how are you? And it's responded back, hi there, it's nice to meet you, how can I help you today? So I'm going to carry on that same conversation. I'm doing well, just having a conversation with an AI, and there we go. So it's great. It's always nice to have a conversation with someone new. What would you like to talk about? And we can actually go on and have a conversation with this. Now, we're not going to do that now because I want to talk about ChatGPT sort of, and see how we can replicate some of those ideas. But what we've got so far is a set of tools that we can use to build our own applications. I'm going to pause at that point just in case anyone's got any questions, and then I'll talk about how we can go about sort of replicating ChatGPT in about 20 lines of code. So anything from anybody?
Not really in the chat, but does anybody have any questions?
If you have, please unmute yourself and ask straight away. This is mind-blowing, Martin, indeed. I think many have.
I have had so much fun with this. Nora, as you might imagine, I have had bundles of fun playing around with this. This is, I think, the thing that blew my mind most of all, and I'll go back to this one earlier on. I know that seems trivial. Who is Brooklyn Beckham's wife? What is her current age? Raised to the 23rd power. But when you actually see the conversation that two language models are having with, well, three language models are having with themselves in order to work out what it is I'm saying and work out how to generate an answer, is really quite interesting. So there's a lot of quite amazing technology going on there. Well, I say amazing, it's not magical. I mean, it's all the magic of GPUs and transformers. You know, GPT-3 and ChatGPT, the system that's built on top of it, is nothing that a huge amount of money couldn't produce. I think someone did a calculation of just how much money GPT-3 cost to train. It's not eye-watering, it's only in the small number of millions of US dollars. But even so, it's probably beyond the realms of what we have access to now as individual researchers. And I think that's an interesting challenge for the future. So some of you may have heard of a language model that was trained in France last year called Bloom. It's based on a very large corpus of scientific documents. And the consortium took over a brand new French national supercomputer to train the model on, that was full of GPUs for the best part of a year. And that was courtesy of the French government and the French national research funding agencies, who felt it was sufficiently important that they delayed the release of this system to their research community in order to create this free and open source language model. So that's not quite ready to use yet. But I'm guessing within the next 3 to 4 months, we're going to see some APIs for Bloom as well. And it's going to be interesting to see how some of these new open source tools are going to compete with the closed source, with the proprietary ones now that we've got from OpenAI, because governments and research institutes and research funders are not going to be too happy about having to fill the coffers, fill the bank accounts of companies like OpenAI. Well, hey, so let's move on a little bit. And
we've got a couple of questions.
Oh, go on.
Yeah. So Julian is asking, could we unpick the conversational aspect a little with itself? What's going on there?
So looking at this one that we're seeing on the screen here. Okay, so what we've got here is a bunch of two tools. There's the search API and another tool called LLM Math. So LLM Math is one of the tools that LangChain provides to translate word equations into actual equations. It also needs to use a large language model, and it's using the default GPT-3 language model, the Instruct GPT model that we've been using all the way through. So they're the three tools that my chain is going to use. So I'm also using an agent. So an agent is sort of a wrapper for all of these things. So I'm initializing an agent with the tools I need to use, the search, the maths model, and the actual language model. And I'm giving it this conversational agent as a layer over the top. So the zero-shot React description one is the one that allows us to have a nicer conversation with it. And I've turned on verbosity because I like a bit of a talk, as you might have guessed. So I want this to react in a similar way to me. So I want to make it more verbose. So I run the agent, and this is the prompt. So I give it the question, who is Brooklyn Beckham's wife? What is her current age raised to the 0.23 power? So I could possibly draw a little diagram here. So it rephrases that question. So it's taken two questions and made it into one. And that's what zero-shot React description's done, is it's made a better question for me to begin with. So it knows what the large language models and the other tools are expecting, and it writes a better question. So there we go. It's written a better question. So the agent then analyzes it and says, okay, so there's definitely a search in there, and it searches Google search via the SERP API tool. There's a Google search for Brooklyn Beckham's wife. Tick. Okay, Nicola Peltz. So it sticks that in a little variable. And then it said, okay, so I've got Brooklyn Beckham's wife, ka-ching, and I now need to find out Brooklyn Beckham's wife's age. Well, I know his wife is Nicola Peltz, so it creates a thought. I need to find out Nicola Peltz's age, passes that into SERP API, which creates the input to the search engine, Nicola Peltz's age, brings back a result, 28 years. Okay, it goes back to its original question. So I've got Brooklyn Beckham's wife, I've got her age, and it now says, well, her age is 28 years. I know that's years, and I know I need to turn that into numbers. So I'm going to strip the age off. I need to calculate 28 raised to the 0.23 power. So that's the calculator action. That's LLM math tool that's going to do that for me. So it's translated. I need to calculate 28 raised to the 0.23 power into 28 raised to the 0.23. It's given me that answer. It goes through its list. I've got that one. I've got that one. I've got that one. Tick. I now know the final answer. It passes those individual observations back into zero-shot React description, another smaller large language model, and it generates a nice phrase for me. Nicola Peltz is Brooklyn Beckham's wife, and her current age raised to the 0.23 power is 2.15, blah, 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 blah. So that's what's gone on there.
So can we give it a go with the variables false? What's going to be, how would the conversation look like?
So should we try, so you want to try making that false?
Yeah, if possible, please.
Yeah, okay. So I've not tried this. Let's have a go. Let's see how unverbose it is. So let's run that again.
Okay.
So the verbosity is only the verbosity in terms of output here. So we still get a similar answer, don't we?
Yeah. And there is another question from Fatima. Do you think
that GPT is self-aware?
No, I don't think it's self-aware. I think it might be able to give an appearance of self-awareness, and this idea of state or memory allows it to pretend to be self-aware. But I'm sure we've many psychologists in the room who we could have a very long, interesting description or discussion rather about what self-awareness is. Because in my sort of naive perspective, it's a very subjective perspective. You can have a conversation with a thing that may appear to you to be self-aware because it exhibits some of the characteristics of self-awareness. It doesn't make it self-aware. But you might then argue, but if it appears to be self-aware to me, does it actually matter?
And then another comment from Eric. He's saying you didn't mention the language of blue.
So I didn't mention the language of blue. Now I will have to go and have another look at it, but I believe Bloom is a multi language model. So it's been trained on a number of European and non-European languages, and I think that was one of the requirements of the funding, which again is going to make it a lot more useful, because many of the conversations that we have and the discussions we have are for language models that are English language models, and we're perhaps being a little bit selfish there, thinking that everybody wants to interact with an English language model, when surprisingly other languages exist in the world. So yes, we do need, I think, more effort into making sure that research into the developments of non-English language models, or multilingual language models, I think more importantly, it is also kept up in research, and not just allowing the sort of Anglo-Saxon dominance of this. But there we go. So there was something else that I did want to have a little look at. So we've looked at conversations here, and very quickly how we can build a sort of ChatGPT. And ChatGPT, as we've sort of maybe seen already, is basically just some very clever prompts, added to which we've got the concept of memory. Now, what we've got here is sort of built on a blog post I read just before Christmas, which is about how we can actually build computationally a virtual machine is a concept inside ChatGPT. And we can basically run a computerized virtual machine inside ChatGPT. We can tell it how these things behave. We can tell it to run some Linux commands, and it will create for itself an imaginary world. So coming back to this self-awareness thing, it will create for itself an imaginary world where we are inside a Linux computer. And it will run some commands for us and run some code, and sort of take it from there. So using many of the same ideas as before, I'm going to tell it a whole load of stuff, and create a template, tell it what it is. So I'm telling it to act as an assistant in the first set of prompts, and then I'm telling it to act as a Linux terminal. I'm telling it I want it to type commands, and you're going to reply with what the terminal should show. I don't want explanations, don't type commands. And when I need you to tell something in English, I'll do so by putting it inside curly brackets. So I'm going to tell it to behave as a virtual machine. So let's run some of this and let's see how far we get. This is remarkably simple, and I haven't got my prompts right on this. This needs a bit more work. But it sort of gets to the point. So I've told it to create this artificial computer inside its language model, and run PWD. And if anybody knows their Linux command line, then if I'm in a particular directory and I run PWD, it tells me that I'm at the root of my computer. Which in itself is quite astounding. But let's see if we can do a little bit more as well. So let's get it to run the ls command inside the current directory I'm in, because remember it's going to remember state. It's going to know where it is. So it should be able to run all of that again. And then look at that. It even knows what directories would exist inside a typical Linux computer. So it's created for itself a virtual universe that it is living inside. So this isn't a real computer. This is a language model that's deciding what needs to be here. So let's try another little command. Change directory into the home directory. So again, we're being verbose in terms of the prompts, in terms of the output here. So we change directory and we run pwd again, and it tells us where we are. So change direction to the home user, press pwd, and it tells me where we were. Now, again, this is absolutely astounding. I've not told it anything about Linux at all. I've just said, pretend to be a Linux computer, behave in this way, and I'm going to give you commands and you're going to work out what to write. But I think what is important here is it's the generation of the prompts that are important. Now, I'll leave it on this one because A, it's a bit cheesy, but B, it sort of demonstrates, I think, as well, what else it is doing. And, you know, coming back to this idea of self-awareness, it's not just plugging away at identifying a single family set of strings. So I've said this time, make a file jokes.txt inside and put some jokes inside it. So it runs all its same stuff again. So not only does it create the jokes, but it knows to actually use the correct command to touch the file and echo some lines inside it. It even knows what to do. I didn't tell it to do that. It knows which commands to use. So it uses the touch command to create an empty file, and then it echoes and does some appending into that file. And they're fairly crap jokes, I have to say. But, you know, it even comes up with cheesy computer geeky jokes as well, doesn't it? You know, how excellent is that? So why did the chicken cross the road to get to the other side? What did the fish say when it hit the wall? Damn. And why did the scarecrow win the Nobel Prize? Because he was outstanding in his field. Oh, goodness me. Isn't that terrible? But we get that sort of idea. So it's created for us a particular set of outputs. We could even get it to do something more complex as well. I'll just do one more and then I'll finish up, because we could go on forever with this. So I'm going to tell it to create and run a little Lambda function, and let's see whether it does that. It falls down on this sometimes, by the way, but you know, not bad for a few minutes work. And I think that's right, actually. I think it is 33. So there we go. So that was it, really. A sort of not what I intended to do, and a bit of a flying visit through interacting with GPT-3 via its API, and a bit of an introduction to this really nice new Python package that I think is going to help us build applications. And certainly this is something that I'm going to have a think about over the course of the next few months, is you know, maybe a little research proposal or two about how we can create tools and not just use tools, but create tools using large language models to help students improve their writing and to give feedback. So as a little plug, if anyone does want to have a chat about that, Martin Callaghan, University of Leeds, get in touch and we can see what's what. So there we go. I've overrun by a minute, Nora, sorry.
Thank you very much, Martin, for a really mind-blowing presentation. That was absolutely useful, and yeah. So there is one more question, if you don't mind. Can we find this collab anywhere?
So can you say that again? Sorry.
Can we find this collab anywhere? I think he's the person he's referring to. Tamim is referring to this notebook. Is that
so? I can make the notebook available. Yeah. Yeah. So we'll make the notebook available afterwards. So I'll put some extra notes in it. Take my API keys out, but put some web links in to show you where to get the information and try a few things out yourself. In terms of other things, there is a little gallery that LangChain have of some interesting tools that other people have created. If people want a little bit of an idea of, you know, a bit of inspiration. So question answering things as well are quite useful. But yes, there we go. Thank you very much, everybody.
Could you share with us the notebook after you just remove the keys and everything else? Yeah,
I'll do that. Yes.
Yeah, so we're going to stick everything in a GitHub page.
We can do that.
Yeah, we keep all the resources there. Thank you very much for your presentation. Thank you, Mark.
Cheers. Thank you very much.